YouTube videos out there about training LoRa's, and what I noticed is that a lot of these people are sort of giving absolutes, like these are the settings you need and this is what you should do, and if you don't do it this way, it's the bad way. And I want to make sure that you guys don't listen to this. um, in my experience in making LoRa's, I've made like 20 or 30 LoRa's. They're not all published, and for each LoRa, you're gonna fail. You're gonna make failures, and in my experience, there's no magic trick out there. There's no perfect setting. So even everything I tell you today, like it's in the end, it's all going to be about experimenting. But there are some sort of golden rules, and in the document, I put them in the yellow box like this. There's a few yellow boxes, and these are just sort of actual rules, like scientific rules, that if you don't follow them, your LoRa will not train, it will crash, or it will be broken. So that's it. So be free, be creative, think outside the box, and screw the people who tell you that you shouldn't do something the way you want to. So any questions about this? I'm gonna try to ask questions between each section. I think until like the mid of this document, we're going to stay on this page, and then we're going to move on to the actual UI of the app. No question, all good. The subjects. So there's 3 categories of LoRa's you can train, and depending on the category, your requirements will change. But let's just go over the three ones very easily. Concepts, and the examples I listed here are like a mugshot LoRa. Every picture is sort of a mugshot, or flaming object where everybody and everything is on fire. Giants, people that are ridiculously huge compared to the environment. Riding, there's a LoRa out there like riding an animal, because the base stable diffusion doesn't do that very well. So that is also a concept. It's not a character, it's not a style. So we call them concepts. After that, we have characters. They don't really need explanation, but when we talk about characters, it can be real people or not real people. So I listed Michael Jackson, Pikachu, and Link from Zelda. And then styles. Style is also sort of obvious. I listed Toriyama Akira. He's the artist of Dragon Ball. Overwatch style, or like manga style. It can be, oil painting style. It doesn't really matter, but that's the other style you can get. And as I said, for these 3 concepts, you're going to have different requirements, and the data set is also one of those requirements that will change depending on what you're training. And actually, I didn't write anything regarding that in this document yet, but we might go over that. So before I move on to the data set, anybody has any questions? All good? All good. So data sets is made of 3 parts, I would say. Quantity, quality, and repeats. Quantity is important for sure, but quality is probably the most important. Quantity is one of the things that you will see a lot of people in tutorial online sort of giving you hard numbers on, and truly there isn't. Actually, in the last class, I tried to make a pug face LoRa, and I only had 6 pictures, and it was cursed, but it was sort of doable, and I think with more adjustment, it would have been possible. But I still sort of recommend at least like 20 pictures to have a minimum of variety, variate. I don't know how to speak English. Variety. How do you spell this word? How do you say this word? No idea, but that's the word. Um, so yeah, you try to get 20 picture at the bare minimum, and you try to get different angles. And I guess this is the step where I should probably share an example. Let me just do something here. By type. I'm going to change the screen I'm sharing. Variety. Wow, this is so helpful. Thank you so much. Variety. Guys, I'm sorry. I'm not sure what happened. Share your screen. I'm going to share this. If it happens again, let me know. I have returned. I was about to come here and read variety again because I needed to say that. For the pug, LoRA, as you can see, all the pictures I had were pretty bad quality, and they are all in the same uh, position. So the results I were getting were very cursed, very inflexible, not flexible. So yeah, you want to try to have as much variety to your data set as much as possible. Um, and, you know, as I said, 20 is the bare minimum. Personally, I always try to get about 200 pictures. Obviously, depending on what you're trying to train, it might be hard to get that much. But once I'm done with this, I will sort of talk about something I didn't talk during the last class, which is loopback. But first, let me just go over the quality and the repeats. The quality is almost more important than quantity because you know, when you train a LoRA, the neural network, the AI you're training is trying to get as much information as it can from the picture, and a picture has a certain amount of pixels to train from, right? And if you have a 512 by 512 picture, it's about half the information you would get in a 1024 pixel picture. The only thing is you should avoid having pictures less than 512 pixels for Stable Diffusion 1.5. And, you know, uh, the word I said is you should try to avoid, but it's doable if you do less, but you will get a lower quality LoRa. So it's best to get at least 512 pixel for Stable Diffusion 1.5, but you can also put bigger images. And I don't know why, but a lot of tutorials online also tell you to like crop the pictures or downsize the picture. I don't do that. I just download the pictures from the internet, and sometimes, you know, they're like 4,000 pixels wide by 5,000 pixels high, and I train on that. It's totally fine. The script is gonna adjust everything it needs to uh, to work on your picture. So don't worry about the size as long as it's at least 512 pixel if possible. 1024 for Excel. You can train on higher resolutions. I don't know if I said that. So in the settings, we're going to go over the UI in the next section so you can see where this goes. But you would be able to train at higher resolutions than what the base model is trained on. So Stable Diffusion is trained on the 1.5 version is trained on 512 pixels, but you could train on like 768, for example. Anyways, enough babbling about quality. The last thing is repeats, and there is also online a lot of people who will tell you that you should get a certain amount of repeats for your pictures. I'm not sure why that is. I personally try to keep my repeats between 1 and 2 and just do more epochs. And I know, like, now I'm saying epochs, and you might be wondering what the hell is an epoch, and we're going to go over that later. But what's important is that um, you don't want to overtrain your data set. It might be useful in some cases, and as I said at the beginning, experiment. But personally, I try to keep it at 1 or 2. And we're just going to go over the folder structure related to the data set, because that's probably one of the most important part of training the LoRA. So you have a root folder for your project. This is my POG LoRA. You want to have 3 folders in there. The name doesn't matter. It really doesn't. This is IMG, but it could be images. Doesn't really matter. As long as you have 3 folders in there, one that's where your model will be stored, one where your logs will be stored, and one where your data set will be stored. And the one where your data set will be stored should have subdirectories in it. You shouldn't put your pictures in here. You should have another folder inside, at least one. And the folder names in here have a special structure, and that doesn't change. Actually, this should be a golden rule in here. I will adjust that after the class. But essentially, what you want to do is start the directory name with a number, and that corresponds to the repeats. How many repeats per epoch you're going to go over each image. So in this case, it's 5. So in one epoch, we're going to go 5 times over each of these images. And then followed by an underscore. That's also very important. And the next word is your class name. And that's very important because if you have no captions for your data set, that's the word that will be used as a trigger word. So you want to have something that's meaningful, but also how can I say, something that would not be easily mixed up with something else. I'm trying to think of a good example here, but like, I don't know, let's say you're trying to train a cat, a very specific kind of cat, like a specific breed. You wouldn't call this cat because then every time you would use cat in your prompt, that's the thing that's going to pop out. If that's not the intended behavior, then you should, pick a word here that's more meaningful, more scoped to what you're doing. And so so you would want the folder to be unique, I guess. You would want the folder to be unique. Actually, it doesn't have to be unique in the sense that you see here, I have 2 folders with the same class name, right? Is it big enough? I'm sorry, guys. I don't know if I can actually make the font bigger. But yeah, both both folders have the same class name, but they have different kind of repeats. And the reason for this is because the ones that have 10 repeats in this case were of not higher quality, but let's say I just wanted to train these more. So on every epoch, these pictures will be the AI will sort of go over these pictures 10 times, but it will go over these one only 5 times. But they will have the same class name. So that's kind of important. Maybe let's say you have a data set and you have, I don't know, 200 pictures, but out of those 200 pictures, maybe you got like 50s that are kind of lower quality, but you think they're good enough to be trained. You might want to store them in a different folder with less repeats so that, we still get some information from them, but not, uh, overtrain the model with these lower quality images. So that's kind of the idea. But you could have like, it's not on this PC, but I have a Star Citizen LoRa where, I have multiple spaceships, but it's all within one LoRa. I would have different folders here with, instead of POG, have different words in there. I guess a good example, let's say I want to make a zoo LoRa. I would have like a tiger, lion, uh, you know, crocodile, whatever. And these would all be in the same LoRa, but they would have different sort of trigger words. So that's the idea with the data set. Now, I want to go over something I didn't go over with the last class, which is it's loopbacks. So loopback is something I kind of do a lot, especially with Stable Diffusion XL. And loopback is basically, let's say you want to train something specific or something that doesn't exist, but like something so specific that there's not a lot of data out there about it. You could generate pictures with Stable Diffusion XL or 1.5 if you get a good quality enough and train on those. But I recommend to be extremely careful about which pictures you would feed back into the AI. So you don't want to train artifacts in your images or this sort of thing. So let's say you want to train something and like 8 images is the best you could get online. Then get those 8 images, train a LoRa, even if it's a bad one, then try to use that LoRa to train, not to train, to generate more images that fit what you're trying to train and try to get not cursed ones. And you get 2, 3, 4 more pictures like this, and then you put them back in your data set. You train another version, and then you create new pictures, and they should be easier to get, and then and so on. You get a few pictures like this, and after doing this a few times, you have yourself you're generating yourself a data set. I do this a lot lately because Stable Diffusion XL just provides such good quality pictures at high resolution. It's really good to have that feedback into the LoRa. It's really good, especially for SD 1.5 LoRa's. I find because I'm training at half the resolution. So I'm gonna write the information here later, but yeah, that would cover the dataset section. Anybody has any question while I take a drink because I can feel I'm losing my voice already. Classy, there is no recording of the first class, unfortunately, but surprisingly, I was babbling even more than I am now. And I think I sort of refined what I'm saying and try to focus more on the matter at hand. It's probably better if you just focus on what I say now, to be honest. The last one was not uh, that great. I learned a lot from my last class. So I'm trying to give you guys a bit of better content today. And I learned variety. I feel so good at this. I feel I can say this all day. All right. You guys see my screen now? It should be only the browser. It should be the Koya GUI. The link for this is in the classes channel. You can download the repo and go through the installation process on your own. I will only cover how to train a LoRa, how to caption your data set, and also I will not be able to train in front of you. I tried this in last class, but my PC just can't handle streaming and training at the same time. So we're going to have to skip that part, unfortunately. So when you start Koya, you're probably actually going to be in the Dream Booth tab, and we're not going to go over this today. It's not a class about Dream Booth, so be careful. Sometimes because the two UIs, they start on sort of the same look. They're very, very similar, except the text box at the bottom. So sometimes I start and I realize later that, wait a second, this is not the right place. So LoRa is the place you want to go. Um, the Before going over this, I'm gonna show you how to caption your data set. You might not always want to caption. I Actually, I think it was the Pikachu LoRa. I didn't have any captions, and I still got some good results. But for sure, captioning your data set will give you probably better results. I don't want to say always, but most of the time, I think it will give you better results. So you go to Utilities. Captioning is the first tab that will open, and over here you have 4 captioning methods. And the one you're most familiar with is most likely the WT14 captioning, which stands for Wi-Fi Diffusion 14. And that gives you tags, like one girl and like just one word tags like this, right? Can you guys see well enough? As where the other captioning methods will give you more natural language. So if you were to use like blip captioning, your caption would be more like Pikachu looking at the window on a rainy day. So most people who train LoRa's, for some reason, they pick this captioning method. Um, this captioning method is very simple and very fast. All you have to do is pick a folder. You pick your file extension, and I recommend you to use txt. And you should note this down because we're going to go over this a bit later. Undesired tags, I don't personally recommend it. Um, I'm not I'm not going to go too deep into this, but some people used to say that you shouldn't put keywords that are related to your LoRa in the captions. So for example, if you're trying to train, you know, certain person, Will Smith, let's say, you should put here like one man. You don't want one man in your data set, but I've never really noticed any difference. But that could just be my personal experience. So I don't really use this. But the most important field here, I would say, is the prefix. And that would be your trigger words. Obviously, what you will put here will apply to every single picture in your data set. So let's say I'm doing Pikachu, I'm going to write Pikachu here with a comma. You want to have that little comma here. And now every caption will be generated, but it will be prefixed by this Pikachu. So when I prompt my LoRa and I put the Pikachu, the LoRa will get triggered. That's where it comes from. And I sometimes use the postfix for some things, uh, but you don't need to worry about it, but feel free to experiment. I honestly don't touch any of the sliders usually. This model is the latest one by default, so you shouldn't have to touch this. Some people play with this, like, are you training more of a character or general concepts? But I've had very good results with this. but I do recommend you to keep an eye on what is generated. So I guess what I could do is caption one right now. I'm gonna do this one. I'm gonna share my whole screen. I hope last time I did that, I disconnected somehow. So if I disappear, you guys let me know. I'm gonna caption hovering. I'm gonna caption sci-fi vehicles. It's a new LoRa's I'm trying to make. These are gonna be hovering vehicles, and LoRa's sci-fi vehicles images hovering. So right now I only have pictures in here. There's no captions. I'm gonna press this caption images, and you're gonna see this thing is gonna start doing some work. It's quite fast, to be honest. It's not definitely not the longest part of the process. The first time you use it, it might download some model from Hugging Face, but that's about it. Once that's done, it's only done once. So it found 31 images. It's done in batches of 8 here. So it's going to do 4 sort of steps. And the captions are already starting to show up. So I'm going to try to find one that's probably best captioned. I guess this is good. So one thing you might notice right away is that the caption files, sorry, have the same name as the pictures themselves. So that's a really important part of the process. Where did my picture go? Am I blind? I wanted this one. Oh, it's this one. No. What? Oh, it's right here. Yeah, so they have the same file name, and there you go. Hovering. It says weapon, multiple boys, gun, military helmet, robot, mecha, science fiction, realistic. So the focus of this LoRa would be sci-fi vehicles. And as you can see in this caption, there's not much that says anything about that. So I would have to go over these. To be fair, this is somewhat of a complex data set, and wife diffusion is focused around anime. I mean, the training data is all about anime stuff, so it will give you strange results if you're doing a bit of a strange LoRa. So I would have to go over these and add more tags to this. But that's all there is to know really about captioning. It's done. So we can go back to the UI. So that's it. We're done here. We can go back to LoRa. Just gonna change my screen back. Any questions about the captioning before I move on? All good. Okay. So the first step you want to do is go to the LoRa tab, and training tab should be the first one. And source model is the model you want to train your LoRa on. And that is kind of important. I think a good example is the other day I was training the POG face thing on Kiwi's checkpoint, but all the pictures, no, that's not true. It's the mullet. Yesterday I was doing a mullet LoRa, and all the pictures I had were photorealistic pictures, but Kiwi's checkpoint is kind of anime 3D-ish, so my results were a bit cursed. So it's important to pick something that fits what you're trying to train. You pick whatever you want. Obviously, if you're going to pick something that is Stable Diffusion XL, you will have to check this SDXL model. That's very important. I don't think anybody does Stable Diffusion 2 anymore, but if you do, you're going to have to check at least this and maybe this one if you know what it's about. But once that's done, you're sort of done with this tab. Next step would be the folders, and that's where the 3 folders I was explaining to you about earlier are going to be set. So I'm going to go to LoRA. I think it was Pug. So images. You see how I'm picking this folder, which has the subfolders in it, right? This is the folder you want to set in here. You don't want to go another level down. You sort of want to have the parent folder. Then the output folder, that's where two things. That's where your model will be output, and also your sample images, we'll go over that a bit later, will be output. So whatever folder you want to use for that, that's the one. And loggings, that's a required folder. You're going to need this. It doesn't matter if you don't care about logs. There will be logs and they need a folder. The other very important part of this is the model output name. And you can obviously rename the file once it's trained, right? Like in the Windows Explorer, but in the metadata itself, it will still be the original name. So you want to name this something that's meaningful. And that's it. That's all you have to do. Regularization folder, we're not going to go over this today. We're not going to use that, so you can ignore. And training comment can be useful if you're doing a lot of experiments like I do. But we're going to leave it empty for now. So this page is done. And then it's parameters. This is where the big brain stuff happens. So before I move on, I just want to make sure with you guys that we're all on the same page. Oh, they changed the UI. I updated Koya this morning and I haven't moved the things to tabs. So if you guys grabbed the version earlier than today, you might want to update. Yeah, Jay, you're probably going to have to do a git pull here. Everybody's good? All right. So LoRa type, and this is the hard part because I could make this class 3 hours. I'm gonna try to keep it simple. You got the standard LoRa, right? Which is not a Licorice. Basically, you have 2 folders in your either A1111 or Comfy folder, but you have 2 folders, right? LoRa and Licorice. LoRa is the standard. I mean, it's called standard. It's the original LoRa. That's what we're gonna uh, look at the settings for right now. But the settings for Licorice are not very different. But I will say that the IA3 one here is not something I recommend if you plan to share your LoRa with people. And the reason for this is that for this specific type of LoRa, it is very bound to the model that you are using. So if you have like your custom merged checkpoint mix and you train it on that and nobody has that model, if you share your LoRa, they will have weird results if you use this IA3 specifically. So just putting it out there. And another thing you might hear from YouTubers and whatnot is that Licorice, like Locon is better at concepts, LoRa is better at style, and the standard LoRa is good at everything but less than these two. And to be honest, I don't find that to be true. It all just goes back to what I said at the beginning: experiment, think outside of the box, break the rules, and break everything. I have tried all of them, and I don't find them to be giving better results. It might take slower or longer, but overall the results do not change very much. So yeah, that was about the LoRa types. I guess one thing I could probably say is that Licorice can fit more information in it. That's why they are usually much slower to train. LoRa will probably train like Jay if he trains a LoRa on his 4090. unless he has a huge data set, he's going to be done in like 5 minutes, literally. So LoRa is the way to go. Licorice, I mean, if speed is important to you and VRAM is low, if you have more VRAM and more time, Licorice might be better for you. Next step would be batch size, and that's also very tied to your VRAM. So I don't know here, I guess K has low VRAM. I'm not sure about other people, but you might want to keep this at 1. But the more you can train at the same time, the faster your training will be, right? You have to be careful. Like in my case, I have the latest NVIDIA drivers. So I can actually put batch 5.4, but because it will borrow RAM from my system, the speed goes down like 10 times. So if you're increasing batch size, but the time it takes to finish the LoRa is longer, then you have to lower it 1 or 2. And obviously, if you're doing stable diffusion XL LoRa and you don't have a 4090, just leave this at 1. That means how many images it will process at once. So it's literally just the same like when you're generating images. If you do 4, it will process 4 images from your data set on each step. So that's what it does. Epoch is the word I kept saying earlier, and that is very important because that is how many times the model will sort of go over your entire data set times the repeats you have. So if you put this to 10 times, epoch 10, it's going to train your whole data set 10 times the number of repeats you have. So if you have 1 repeat, then it's just, 10 pictures times 10 is going to do 100. It's going to go over your pictures 100 times. And yeah, that's it. That's usually where you want to sort of have a high count of epochs. It's better to train slowly, have a lot of epochs to pick from, than train this one huge epoch, and then the result you're getting is not good. So it depends on the data set, obviously, but I usually have this between 20 and 50. I put 50 if my data set is small. This you don't need to care about. Save every npog. That if space is low, if you don't have a lot of storage and you don't want to save every epoch, you might want to change that. So maybe you want to save only every 2. I usually leave it at once because storage is not a problem. Caption extension, very important because this is what we talked about earlier in the utilities. And yeah, right here, this extension. By default, this box will be empty. And as you can see here, there are presets. You can pick some of these presets. But when you pick those, either it will be empty here or it will be some weird formats you're not familiar with. So you want to make sure that your extension here is right. Any questions so far? I'm going to go almost over all of these. So I know I have 15 minutes left, but it's just going to keep getting more and more complicated. So if you have any questions, it's better to take care of them now. I'm going to take a drink, just a second, because my voice is going away. All right, all good, I guess. So next step, mixed precision and safe precision. Both of them have the same options, except the first one, but it doesn't matter. What's important to know here is that if you have an RTX 30 or 40 series, you want to keep this at BF14. I have a 4060, so I put this at BF16. If you have less than an NVIDIA 30 series, like 2000 series or a GTX or whatever, you're going to have to use FP16. It doesn't change anything about the VRAM. It doesn't change the speed. It doesn't have any visible impact for you on the training. Then you can ignore this. The seed is somewhat important if you are experimenting and you want to fiddle with things and sort of see changes. This seed concept is the same as when you're generating images. Like the same seed will give you the same results. So as I said that at the beginning of the class, you're going to train a LoRA. You're going to train like 3 failed ones before having a good one. And you're going to have to mess with the settings. So it's kind of good to set anything here, but sort of stick with it so that you have something to compare with between your runs. That's it. I'm going to let this top art bot finish because it distracts me. Um, And then this step is also very important. Cache latents. You want to, sorry, Jesus, I'm dying already. You want to keep this cached. You want to keep this checked, sorry. And this is what you really need to make sure it's checked. And the reason for this is every time you're going to train your LoRA, and it's going to fail, as I said, it's going to go through this latent caching process. But the thing is, if your data set is kind of big, it takes time, really. In general, for me, this process takes about 4, 5, sometimes 20 minutes. By caching the latents to disk as well, it will only do it once, the first time, and then the subsequent runs, it will load them from the disk. So I highly recommend you to do that. It, in general, it's about twice the size of your picture. Like if your picture is like 200 kilobytes, that this is going to be like 400 kilobytes. In my experience, I could be wrong there, but it doesn't take much space. It's worth having it kept there. Next step is learning rate, schedulers, optimizers, and this is the trickiest part. And this is where you will most likely spend most of your time when training, really. Um, learning rate is just how fast should you learn? And this is the same as training humans. If I gave this class in 5 minutes and I gave this class over 5 days, you will have understood more information. After 5 minutes, you won't really understand anything. Like you might remember one slider. So that's sort of the same thing. Train too fast, and your model will be burned and doing nonsense. And train too slow, and it's not gonna do anything you want it to do. So it's really a sort of trial and error there. In the Notion page I shared earlier in the classes channel, I put some presets there, and I encourage you to sort of play with them. I kind of recommend you to use an adaptive optimizer. So there's two types of optimizers. There's non-adaptive and adaptive ones. And the difference between those is that an adaptive optimizer will sort of try to find the accurate learning rate for you. Usually, I think the variables, the value it's looking for is between 0.1 and 1. So it's still, the learning rate is still relevant, but it's less granular than usual. Usually, you're going to do like increments in very small amounts, while adaptive is much bigger increments. What's important to know here, and I don't know why they separate it so far, but you have learning rate here, and down here you have text encoder learning rate and UNet learning rate. And if you have nothing here, you see it says optional. If you have nothing in these boxes, this main learning rate will be used. And the other important thing to know about these two is that if you use an adaptive optimizer, it has to be the same value. But the script will tell you if you're not doing that, it will not train anyways. So I'm just putting it out there. Now, what's a text encoder and what's the UNet? Because it's sort of important to know, especially if you're going to use a non-adaptive optimizers. Text encoder is sort of how the LoRa will interpret your prompt during the generation process. It will associate certain things to neurons during the training process. So for this, like if you have no um, captions, it might not have as big of an impact. But you know, if you have captions, it's good to have to train the text encoder to make sure it kind of associate things together. And the unit is just the general network of the LoRa and stable diffusion. So that's sort of your main. Usually the text encoder will be lower than the unit, but for adaptive optimizer, they are the same values. Sorry about that. But yeah, that's it about that. The scheduler, I don't want to go too deep into this. It can be a bit complicated, but that's how the learning rate changes over time. I recommend you to keep it at cosine probably. In the document I shared, there's more there and there's information about those, and you can experiment, but I will not go over these. It's a bit too technical for today, I guess. I might go into deeper details if some people are interested in the future. The warm-up thing here is kind of important if you have a big data set. And when I say big data set, I mean like a few hundred pictures. You want to sort of warm up. 5 to 10% is a good value. When I have a really big data set, I usually have it at 8. So just putting it out there. Before I move on to the next steps, I forgot to mention, if you're going to use adaptive optimizers, these things are very sort of technical, and I have the links to the papers in the Notion for those interested, but these optimizers will require extra arguments, and those are required. So in the Notion document as well, I put the arguments that are required, and you can, you know, adjust the settings there, but you will need those in here. So I guess that covers the learning rates for now. Any questions before I move on? Am I going too fast? Is my English hard to understand? Variety. Getting there. Perfect. Awesome. Your English is better than me. Max resolution. This is really important, and that's what I was talking about earlier. So if you're going to train Stable Diffusion 1.5 LoRa, you want to have this at least at 512 by 512. You can increase it by increments of it should be a multiple of 8. This is my personal recommendation. Computers just like that. So you know, you can increase this to 576 by 576. It's something I've seen. 768 by 768 is also something I've seen. But something you should know is that as you increase this resolution, so does the VRAM usage during the training, and it's quite a big difference. And for Stable Diffusion XL, you want this to be at least at 1024, and if you want to increment, you have to increment by increments of 8 as much as possible. Yeah, 512 by 512 is probably best if you just want to start, you know, training one LoRa. You can get excellent results with this, to be honest. Obviously, you will get better results with higher resolution, but if you're starting, just start with this. It's faster to practice, if you will. Buckets is a bit of a complicated process. I don't want to go too much over it, but essentially it will sort of break your data set into different resolution around your main one. Either I turn this off, or if I use it, I do not use like extreme values like this. I will probably bring that down to like the double of what I set here and half for the minimum if I leave it on. The next really, really important thing is the ranks and alpha. This is directly related to how much VRAM you're going to be using during training, and also how much information you can store in your LoRA. And that means it translates to a bigger file. So if you would train a LoRa at like 192 or something crazy like that, your LoRa will be huge. This is probably going to be like 1.2 gigs LoRa. So you want to adjust there. And depending on what you're training, there's sometimes like no benefit to increase the number beyond a certain point. So I actually made a table in the Notion page as well with the settings I use, depending on how big your data set is, how diverse it is, and like what sort of thing you're training. Is it a character? Is it a style? Is it a concept? This value will change, and this is sort of the main value. It's the rank, sometimes called dimensions, and the alpha is sort of a dampener. It's it's really hard to explain, but usually you want to either keep the alpha at the same value as the rank, half, or one, just one. Don't put it below one. But yeah, that's the rule. So usually, in general, I will try to train this at 64, and I will have my alpha at 32. That's kind of a good point to start. If you have less VRAM, I would probably recommend starting at 32 and then 16, and adjust from there. This is, as I said, entirely related to how much information it's gonna learn and store from your data set. All the other options down here are sort of optional. You don't really have to mess with these, but there are recommended values. Just play with it and go along with that. I guess that ends this page, but I want to add that if you're going to use Licorice like LoHa, Locon, you're going to have a second slider here, you see? Convolution rank and convolution alpha. And while there's no rules about these either, I personally tend to do the same thing. So here I have 3216. I'm going to do what I mean by same thing is doing half. So I'm going to do 16 here, and maybe 8. But yeah, generally speaking, you want to have the convolution lower than the network one. I think if you put it higher, it will actually crash. I'm not 100% sure on this, but yeah, that's the general rule for this. And this is like the most simple settings, if you will. Then there are advanced settings. I don't want to go too deep into this, but I want to cover some things. One of them is the gradient accumulate steps. If you don't have a lot of VRAM, you might want to use this as it sort of emulates batch numbers we were talking about, batch size. If you cannot have a bigger batch size than 1, you might want to try to increase this to 4. It will sort of create a virtual batch size without increasing your VRAM usage very much. So that's something to keep in mind. If you are like Jay and you have a 4090, you know, don't even worry about this thing. The other thing I see here is clip skip. If you're going to train a Stable Diffusion 1.5 model, you might want to set this to 2. Personally, I have never tried it now, but it just sounds logical given we do this during generation as well. Another thing is, oh yeah, you want to check this if you're going to use the gradient accumulate steps, I think, not 100% sure. But I think this needs to be activated for this to work. The other thing I want to bring to your attention is flip augmentation. If your data set is small, this is very useful as it will sort of add pictures in your data set with random, not orientation, but like it's going to mirror some images. It's going to flip some images. So it can give some variety to your data set. But be careful if you're training something that's asymmetrical, that is not symmetrical, you might not want to check this as it will give you weird results. And for those of you who are big on experimenting out there and just trying things, I know you might think, hey, wait a second, I don't have a lot of memory. I want to use memory efficient attention. Please don't do it. You got here Xformers. It's already doing it. I don't know why they keep it here. I think this is just memory efficient attention without the whole Xformers thing, but you probably don't want to check this. It's been there for too long. This, I wouldn't touch it. If you use buckets, I usually keep this, don't upscale. I don't want them to touch the quality of my images. And I usually keep the resolution steps between 64 and 32. As I said on the previous page, the buckets will sort of create different batches of resolution from your data set. And those batches will be made at steps of 64 in this case. Noise offset is something to keep in mind, at least for Stable Diffusion XL. You want to have probably 0.357 is the noise offset that Stable Diffusion XL was trained on. So if you're doing that, you want to use that and adjust from there. But what noise offset does is sort of give you brighter whites, darker blacks. It also works for Stable Diffusion 1.5, by the way. There are recommended values, but yeah, that's about it. One thing I want to add is samples. That's kind of important, especially when you're gonna, start doing this. You want to sort of have an idea of how your training is going, and that's how you're gonna do it. You usually want to do this on a certain amount of epochs to know if your epoch is good or not. So I usually do it on every one epoch. If you don't have a lot of VRAM, it does use a lot of VRAM when you do this. So, you have to mind that. But with 8 gigabytes of VRAM, I can do that, no problem. So all the options are here. It tells you everything. There's an example there. These pictures will be stored in your output folder in a samples folder, subdirectory. And that is super useful. And I'm going to show you, I know I'm kind of going over my time now, but I want to show you why it's important to use this feature. I'm going to go to LoRa's, and yes, this is the one. So I was trying something really extreme. So I found this really old painting artist. He has very sort of, simple, not simple, I don't want to say simple, but it's very raw kind of paintings. And I wanted to get I wanted to get his style, and I wanted to practice on Pikachu pictures. And I want to show you sort of, like, I had 6 runs on this, 5 runs. And I'm gonna adjust this. So each of these pictures here are every 2 epochs in this case. But like you can see that the change is very small on every epoch. This is epoch 20, and there's barely any change. It doesn't really look like the guy's paintings. And it's same for the castle I was doing. There's not much change. So I knew that my training settings were wrong. And then on the second run, I was also making pictures every 2 epochs. And I noticed that, again, it didn't feel right. After 8 epochs, it was still not picking up any sign of the paintings of the guys. And then that's where this thing happened. I changed the settings after that run, and right on epoch 4, it was burned like this. Like there's no Pikachu in sight or anywhere. So that's why generating the samples can really help you sort of gauge where your training is going. This one, the previous run was the learning rate was too high. It was learning too fast, so it got burned. So I lowered it, but then I lowered it too much. It didn't really learn anything again. And then on the final run, you could start to see on this epoch, that's when I knew, okay, this is going in the right direction. This is epoch 4. And as it went on, it just kept getting simpler and simpler. And you see, like this one was not good. Uh, but as it went on, at some point, you're gonna see when like the LoRA starts to get burned because this character keeps showing up. That's when you know, like, okay, I went too far with this, and you sort of pick the epoch you prefer before that. As I said, the models get all outputted, so these are all my epochs. So I can just drag and drop these in A1111 or Comfy UI and test with these and find the ones that I like the most. It was a really fun experiment to do this. Um, yeah, one thing I wanted to talk about is loss, but I cannot show you. Um, yeah, I guess I'll have to skip that for today because if I train right now, my PC is gonna crash. So I guess I have to sort of end it here. I mean, I still have time, so if you guys have questions, just want to talk, I'm here. But that's what I got for you. Mm, Go ahead. Why is it okay to have images different than 1024 by 1024? Why is it not okay? Uh, the resolution doesn't really matter. Um, I mean, it does matter in the sense that you should have there's a minimum that you should go for to avoid, getting low quality. But the script will take your images and feed it to the network to learn, and the resolution doesn't matter. I cannot find any better reason than it doesn't matter really. That's the best I can give you. It just works. So I can have any ratio other than square. Yes, you can. Absolutely. I actually never, I don't even know if I have one square images in my data set. So you don't need to go, as I said, like many YouTube videos, they will tell you should crop your pictures, you should align your pictures and whatnot. You don't need to do this. Just take your picture, dump it in the folder, and train on that. If you guys want to see some things, or like I can share my screen for anything, can answer any questions you may have. If you guys want to speak to, you can come on the stage and say something. Yeah, there's a lot of stuff. I think the document will help, Mashbook. I don't know if you've seen it, but I put some tables in there with like the settings I used and recommended settings, so you have something to sort of get started with an experiment. I'm not sure what kind of GPU you have, but just to give a baseline to everybody, I got a RTX 4060 with 8 gigabytes of VRAM, and training LoRA with like 20 pictures at 512 by 512 for stable diffusion 1.5 takes me about 7 to 8 minutes. Stable diffusion Excel takes me about 1 hour to 2 hours. Yeah, it's not bad, Jay. Yes, Excel is really using a lot more. I'm definitely grabbing that dock. I have a 3080. Yeah, 3080. You're probably. I don't know if you're going to be faster than me, but you can definitely fit more in there. You probably can have a higher batch size than I can, and therefore train faster than I can.